Hello everyone and welcome back to Winter Data Meetup. It's the second day of our data conference. My name is Alex and I'm a host for this session. I hope you're finding our sessions insightful and inspiring so far. Meet Michael, data analyst consultant, ready to share a new way to improve software development planning. Learn how AI prompts and Gen AI can improve your team and make development faster and smarter. Don't miss the session on using power prompts to boost efficiency and innovation in software development. And before we jump into our session, I'd like to take a moment to ask you for your support in growing our community and recognizing our incredible speakers. If you enjoyed the session and our discussions and mostly want to stay updated on upcoming events and talks, please take a second and hit the like and subscribe buttons below. Your participation helps us to reach a wider audience, allowing more people to learn from these insightful discussions of world of data and AI. Also, in the video description below, you will find a link to the talk, where you can share your feedback, award speaker a badge, and rate the session if you like or maybe if you don't like it. Your input is incredibly valuable. It helps us to improve future events and ensures our speakers get the recognition. Additionally, we'd love to hear from you during our talk. If you have any questions or insights, feel free to drop them into the chat. We'll gather your questions for Q&A session and discuss them with the speaker after the presentation. Your contribution make the discussion even richer, so don't hesitate to participate. And now, ladies and gentlemen, welcome our speaker to share his valuable insights. Michael, floor is yours.
Great, thank you very much. And thank you so much for the invitation by the organizers in DataZen. It's a privilege to be here. And today we'll be talking about enhancing the software development lifecycle efficiency using power prompts with what I'm calling the Belbin framework. So let's go through who I am and what I do. I'm a data analytics consulting manager for EPAM with 2 decades experience in biomedical analytics. I have a PhD from Oxford and prior tenure as a professor with multiple fellowship awards at the London School of Hygiene and Tropical Medicine. And the goal today is to look at advanced prompt engineering in Gen AI. And we can then use analytics to assess whether these advanced power prompts can solve 3 separate scenarios. One, in section 1, is a common Gen AI training exercise. Section 2 is solving complex data sets. And section 3 is a main focus of the talk, which is the software development lifecycle. In generative AI, this is a stochastic process, and therefore the variations in output are captured by a technique called iteration in all the examples I use. So before we go on, we just need to briefly explain what zero-shot prompting is. So a zero-shot prompt is a prompt query for Gen AI, such as ChatGPT. In this example, we'll be using the model for Omni. And this is a prompt that lacks any context or examples. So here we have an example. Identify and list all the biomarkers of prostate cancer. And we'll be looking at that later on in the talk. If we look at a single shot prompt, this is a quick query with a clear example. So we include the above sentence, and then we would include the following: that a biomarker is a bioorganic compound, indicating a hidden or future risk of cancer. For example, prostate-specific antigen, PSA. And a few-shot prompt is the same as a single-shot prompt with multiple examples. And effectively, RAG is a good example of a multi-shot prompt. Okay, so why are these important? And this is a classic piece of research, which is in Phoenix and Taylor, Prompt Engineering for Generative AI by O'Reilly. And what we have along here on the x-axis is a number of examples in the prompt that's going into the Gen AI large language model. And on the y-axis here, we have the percentage accuracy. So when we have no examples, zero-shot prompt, in this particular large language model, this would be 17 billion parameters, is equivalent to ChatGPT 3.5. And the accuracy of the answer is very low. If we include, and these would be LLMs such as Llama, if we include a single example of what we're looking for in the prompt, the accuracy zooms up to around 50%. This is essentially GPT 3.5. So in the more modern examples, it's going to be higher. More modern LLMs, it's going to be higher. And the accuracy will increase as the number of examples increases thereafter. Now, that's all very well, but the key question is, often zero-shot prompting is unavoidable. So how do we increase this part of the graph to move it up here? And this becomes an area, this area is really power prompts. This is my own term I've used. And what I mean by that is a prompt that has a large improvement on the accuracy and the reliability of GPT's response. So an example of a power prompt is to include the prompt, but simply use the power word step by step. And this is called a chain of thought prompt. And Phoenix and Taylor went into this in a lot of detail. And in most queries, step by step will improve the accuracy of your response, regardless of what you're looking at. There are more advanced power prompts. The tree of thought is one of them. And this is accessed by having your prompt and then simply put, solve this using a tree of thought. And certainly GPT immediately understands what you mean, and it's a different method of problem solving. So it will activate a different way of giving you your answer. And then there's this area called committee prompts. Now, this was a large area of interest for some time and often involved very complex, what I call meta prompts. So you'd have your query and then you'd have a whole load of stuff below it. And it's supposed to try to activate a committee structure. And I had a look at these, particularly it was important for a client project in Gen AI training. And what I concluded as a result of that was that the committee prompts didn't really work. And what I replaced that with was a concept called the Belbin Prompt. And we'll come on to what that means in a moment. And then there's a final area of power prompts called knowledge prompts. This is my term. And this is accessed. And again, this is my own term. Using the power prompt, use a tree of knowledge. And in O'Reilly, Phoenix and Taylor 2024, they did the same thing using a power prompt with incredible detail. So you'd have your query, then you have with incredible detail. Okay, so there's 4 types of prompt: chain of thought, tree of thought, committee, and knowledge prompts. This is my term, and what I'm introducing today is these 2 concepts of the Belbin prompt and the tree of knowledge prompt. And this largely stemmed from 2 client projects, one in training and one in using generative AI, which I will discuss later in the talk. So if we go to section 1, what we're going to do is we're going to go through a classic Gen AI training scenario. So this will be to teach individuals, clients, how to use Gen AI. But in this particular example, particular for this talk, so this example has not been used for clients, we've added a twist. And that twist is basically a trick question. So we have a scenario, and we want the Gen AI to solve that scenario. In this case, we're using GPT for Omni. The same would be true of just about any of the major LLMs. And what we're going to do is feed that scenario into GPT-4o using different prompts under a concept called iteration, which we're not going to cover in this talk. That's too complicated. And we do internal and external iteration to make sure the answer is robust. But if you want me to go through that, I can do that in the questions. So what we're giving it is a trick question. And we're saying, you have a developer here in the morning. They start work and they pack their bag. And in that bag, they put in their badminton, their sports equipment, and then they put in their notebook, orange notebook. And this contains company passwords. So, I mean, to flag this up now, this would be in violation of most company policies to have such a notebook. And what we do, but we're not telling the LLM that. We're simply giving it the scenario. The developer goes to the subway. They go to a meeting. They go to their office. They go to a meeting. They come back and they see that their backpack zip has broken. So it could have broken anywhere. They don't think anything about it. They go to lunch, and over lunch, they play badminton, taking their backpack with the orange notebook and the badminton equipment. They're in a hurry in the sports hall. So in the changing room, they tip their backpack upside down to get all the equipment out. Play badminton, come back to the office, notice their notebook is missing, and then they report the notebook as missing. So at no point in here are we saying there are security problems, but in this example, that's the obvious thing that's gone wrong here. It's not the fact that the notebook has gone missing that's the problem. It's the fact that the notebook exists at all. Okay, so let's see. So what we've done is we've submitted that scenario essentially over 400 times to the LLM. And then we've written code to harvest out the response. And we've used 4 different prompts. We've used the Belbin prompt, which I will describe in the next slide. Chain of thought prompt, tree of thought prompt, and no power prompt at all. I've called it here trigger prompts, but we would say power prompts. And here's the responses that we would receive from this. So we've got around 1,000 iterations, 900 iterations, and here's the responses. We have a computer security issue. We have an issue with team morale. And then we have locations. So where is the notebook? It's in the office, it's in the subway, it's in the badminton court. It could be somewhere else, okay? That's the situation. And I think from this graph, we can immediately see that of these power prompts, only the Belbin prompt has identified 80% of the time that there's a major security concern. 20% of the time it's identified that there's a team morale problem. And then it doesn't really know where the notebook is, but that's not really the purpose of this particular exercise. If we look at the other prompts, power prompts, the chain of thought is not sure. The tree of thought is pretty clear that it's in the badminton court. And if you don't introduce any prompt, again, it's not so sure. Okay, so it's a pretty dramatic example that this power prompt is making a big difference to the output. So just go through the results again. The Belbin prompt identified there were security issues. So what it would say is change the password, go through security protocols. It identified that within the developer's team, there would be morale problems and would then advocate morale support. It was uncertain about the location of the notebook. In all the other prompts, it simply failed to identify there was any security concerns. There was no mention of emotional factors. And then it was generally, again, uncertain about the location of the notebook, except for the tree of thought. So the question is, the Belbin prompt has definitely got exactly the right answer. We only asked it, where is the notebook? We didn't say there was a security problem. And the question is, how did it do it? Okay, so this is a prompt, solve using a Belbin committee with team roles, step by step. You don't need to include this word. Include the chair's report. That's all the prompt simply was. And now the question is, why is it working when other approaches are badly failing? So we want to go through what a Belbin committee is, and that's a management theory process where you have different team roles to obtain a balance in the outcome. It was a very popular management theory in the 80s and I think particularly the 90s. And the idea is that you would have a 10-person committee and each member of that committee would have a different role in what they were wanting to achieve within the committee structure. So you'd have a plant, an ideas person. You'd have an evaluator or an analyzer. You'd have a team worker for morale and team support. Then you would have a specialist. And then to wrap it up, you would have a chair. So you go on. And in GPT, often it uses a 10-person committee to analyze the role from different perspectives. And what it's doing in this example is it's using a specialist. And for some reason, it picks up that the specialist is a computer security expert. That's what it invariably does. And then it uses a team worker to identify there are emotional problems here. That this is a distressing issue for your company passwords and your company infrastructure is compromised. That can negatively impact your team. So let's try to go through. This is a real-world example over here. And here we have our example. So we have solve the problem. So this is a problem here using the constraint. So the constraint is simply solve with a Belbin committee with team roles step by step with the chair's report. Okay, let's see if that works. And now it's going to do the GenAI process, where it's going to repeatedly now go through the Belbin committee and analyze a problem from different perspectives. Here we can see the chair, investigator, strategist, data analyst, risk management. Now, typical here, it hasn't included the expert. So it's going to struggle to come up with this as a security issue. So I'm going to cheat. And here we come out with the conclusion. And in this particular example, 20% of the time, it has identified there's been security reasons. Okay, so it's sort of, even without a specialist, it's sort of got to a reasonable answer. We can then go on and say, can you include the specialist in that? And then it will, as soon as you ask it to include the specialist, it will then hone in on the security risk for this particular problem. And the way it simply works is that we've achieved team balance, and we can, if you ask it now to put a specialist in, it will say, yeah, I understand what the specialist is, and away it will go and get the answer. Okay, let's go back to the main presentation. So that's how it works. And what's of interest in this particular example, I think this example is not really that important. What's important is how you apply it to complex situations. Now, I'm going to give you an example where actually it didn't work. And you've got to keep in mind here, I am a biomedical specialist. So I have done some client work, not on prostate cancer, but I have done some client work with biomedical problems. And in this particular example, I'm going to focus on prostate cancer, which is a big focus of public concern. At the time I was doing this analysis, it was November. So it was, I guess that's Men's November. It is, globally, of course, it is one of the major causes of mortality in men. GPT-4 Omni has around 1.8 trillion parameters in it. So it has just about all the data of prostate cancer inside its memory banks, inside its databases. There are hundreds of prostate cancer biomarkers known, and they vary in importance. So a biomarker here is an organic compound, which indicates the hidden or future risk of cancer. And an example would be prostate-specific antigen. And the prompts here provide proof of concept for summarizing complex data. So what I want to do is what I want these prompts to do is to give me what I understand about prostate cancer biomarkers. And I did this exercise, and I simply had the prompt here is describe and list all biomarkers of prostate cancer, and I used iteration. Most or all of these zero-shot prompts, these power prompts that I'm describing, failed, but 2 of them succeeded. Now, the failure is a consequence of something called iteration. So what you're doing is you're getting the same prompt to do the same query over and over and over again. Now, really, there are about a couple of hundred types of biomarker that we know of in prostate cancer, but there are possibly hundreds of thousands of genetic types of biomarker. So we're not going to go into this, but what most of the prompts did on iteration, or but two, was that they got confused between a genetic type of biomarker and a biomarker. And this caused the query essentially to fail. So what we're going to look at is the two that did succeed. So the Belbin fell into the same trap. It looked too closely at the problem. It didn't see what the answer was, but two of them did succeed using this technique called iteration, and these are 1,000 iterations. And here's the output, and these were the tree of knowledge prompts. So the one that I introduced was use a tree of knowledge, or these are knowledge prompts. I introduced the idea of use a tree of knowledge. Phoenix and Taylor introduced the idea of use incredible detail. So both of these are essentially power prompts, and we can use them to start investigating how much of the biomarkers in its database can it give us to summarize, as an example of summarizing very complex data sets. And there was two very different responses, and I don't understand why. And this was repeated. This is quite common. One was where it seemed to identify around 30 biomarkers. This is a number of biomarkers in yellow, according to a tree of knowledge power prompt. This is a number of biomarkers according to the incredible detail power prompt, here and here. This is a number of categories of the biomarkers in orange, here, number of categories in orange according to this power prompt, use a tree of knowledge. The green is a number of categories according to the power prompt, incredible detail. And I think just as a brief overview, it's pretty clear from this that this power prompt, tree of knowledge, considerably outperformed this power prompt, incredible detail, very significantly. I mean, here at most we're getting maybe 15 different types of biomarker. Over here, we're getting 50 different types of biomarker. And for some strange reason, the iterations fell into two different types of camp. One is where there was around 30 biomarkers, and the other was about 50 biomarkers. And that was repeated over here for this power prompt. I don't understand this dichotomy in the outputs. So what I'm doing is I'm firing at it again and again. I'm firing the same request at the GPT again and again, and simply harvesting the results, coding them and putting through to this graph. But I think it's pretty clear that this outperformed this power prompt on a complex data set. And let's go through and look at this in practice. GPT, I've got the prompt prepared here. Describe and list all biomarkers for prostate cancer using a tree of knowledge. Okay, let's see what happens. Okay, so now it's going to go through and give us a very detailed summary of different biomarkers. It is, GenAI is stochastic, so every single time you ask it, it's going to give you slightly different responses. And it's given you the category of biomarker here, and within that category, it's going through the different subcategories and subcategories. Here's PSA.
Reproduciendo desde Michael's Mac Mini.
Here is the second category of biomarker, and it's simply going to go through each category. This is a very important category of biomarker, by the way. Circulating tumor cells. This is a very bad biomarker for prostate cancer, or any cancer for that matter. Category 4, non-coding biomarkers. These are advanced biomarkers. So it's given us a very comprehensive list. Metabolic and lipid biomarkers, image-based biomarkers, an area I don't understand. immune and inflammatory biomarkers is a very topical area. And here it's actually given us 9 categories of biomarker, which is more than normal. And I think we can see that this is very comprehensive. It enables us to look at a very complex problem and skim over it very quickly to get a broad overview. Okay, so let's go on to the main area of the talk. Which is the software development lifecycle, SDLC. And the reason why I'm so interested in this is what I do in my job is there's a lot of time pressure to come up with the exact solutions at the right time, under time pressure. And strategic errors are not cool. And I think that we, as data analysts, we all go through strategic errors in any sort of analytics, in any sort of software development. And what the power prompts have the ability to do is identify those strategic errors ahead of time to help in the software development lifecycle planning. So here I'm going to go through, this is just one example. It's not the only example I've been able to successfully use this Belbin prompt, but it is an example I'm giving you more detail on, and critically an example where I've gone through formal analytics to look at the response. So in this pipeline, what we're doing, we're using generative AI to do redlining, and redlining is where you compare 2 legal documents, in this case, compliant documents for changes. So you will get one historic document and you get an updated document. These can be very large documents, like 20,000 words. And within that 20,000 words, what you want to do is get GenAI to identify the differences between them and assess whether there's a significant shift in the meaning. One of the key things that we know about this pipeline is there is a problem with the token limit for the documents we're using. So if you submit 2 20,000 word documents into the generative AI, into the LLM, you're going to go very close to the token limit, so its ability to understand those 2 documents. And the area, the technical area is called choke points. So what I want it to do is look at the framework and tell me where are those choke points ahead of the project. So what we're going to do is we get 2 compliance documents. One is PDF, the other is web-based. They come into the repo. As soon as they come into the repo, it triggers RabbitMQ here, the messaging system. And RabbitMQ will now issue a message to the scraping and pre-processing of these documents over here. It will also then, once that's done, that's going to go through to MongoDB and store, so NoSQL database, and store that pre-processing. It will then notify the GenAI analysis. The GenAI analysis will then go to NoSQL, pull down the documents, start analyzing them for redlining, so comparing 2 legal documents for changes. It will then put the response back into MongoDB, and the user will then query MongoDB directly. So that's the pipeline. And within this pipeline, we want to know where are the choke points. So we can use our power prompts to start asking it. So the real world choke points in large document analysis, in my experience, is called a phenomenon called lost in the middle. And this is a really tough cookie to crack. And what happens in lost in the middle is the large language model analyzes the start and the end of the document, and it omits all areas in between. So in this particular example, what we're calling legal redlining, this is catastrophic, because what will happen is, we'll come on to why in the next slide. Now, the token count doesn't necessarily need to be exceeded, but in a lot of these examples, it's very close to the token limit, not the token count, sorry. The token limit doesn't need to be exceeded, but it's very close to the limit. Now, there is a second choke point, and that's a variation in the document types. So some legal compliance documents have multiple columns. Some rely very heavily on tables, especially compliance documents, and that's a major problem. It's a major choke point in dealing with legal compliance documents. And just to note, none of this information was placed in the prompt. So just to go through, again, lost in the middle. As an example, if you feed two 50-page PDF compliance documents into GenAI, into an LLM, GPT-4 Omnia was an example here, it should have yielded greater than 300 differences. The old versus a new version. In fact, the answer was it actually yielded less than 7 differences. And those 7, of course, were at the beginning and at the end. It's a classic lost in the middle error. And if you're not aware that that's going to be a problem, that really is an issue, because you'll generate serious bugs in your framework and not understand that those are bugs. So in this case, SDLC planning is essential. So in my personal experience, solving this lost in the middle, real world solutions, in my personal experience, this is what I would do. This is how I solved it, is by document partitioning and chunking, splitting, dividing, chunking, sectioning, and segmenting your documents. You can use a technique known as sliding window analysis. Now, in what I come from, the area that I come from in biomedical analytics, we use that a lot. Outside biomedical analytics, it's not really used. So it's a solution that I understand very well and can code that easily. And the other area is token management, because you can go through compression, token reduction. So there's a lot of ways to solve this thorny issue of lost in the middle. So we put all that to the LLM. So we put the query. We don't have time to go through the exact query, but we put the query in that we have documents which are 20,000 plus words. There are token limit concerns, and then we subject it to the different power prompts: chain of thought, tree of knowledge, Belbin, tree of thought. And here we have the different choke points it's identifying. So we're saying identify the choke points, and here we have 500 iterations for each query. That's how we're generating the frequency here. So the yellow is we have a lost in the middle. We have a token problem. Now we've already told it there's token limit concerns. So it said that the choke point is tokens. The other is there's data issues. Now, a typical data issue here is, as I've gone through before, compliance documents have multiple columns. A lot of information can be held in tables, and those are difficult to pre-process. And then there's framework issues, integration, optimization, performance. And as we go through all of these, only the Belbin committee really hit the nail on the head here, that there is a major concern about data issues. And that is not trivial to solve. How you pre-process accurately at legal level, at the very highest level of scrutiny, a table, is not a trivial problem to solve from PDFs. And so in this framework, realistically, only the Belbin really succeeded in understanding the entire problem, because it's not just you have lost in the middle, but that's a major problem. You have data issues. And it was able to identify specific data issues that I was able to recognize. Okay, so we're going to go through a second round of analytics. So what I'm going to do is I'm going to take these yellow dots here in this graph and subject them to what is it actually saying in those yellow dots. So I'm reiteratively just churning requests into these LLMs. I'm harvesting the answer. I'm analyzing those answers. And here's the recommendations that it's making, how to solve this lost in the middle problem. So here's document chunking. Here's sliding window. Green is document partitioning. Dark green is hierarchical partitioning. Blue is token management, and gray is other methods. And this is for 500 iterations. So this is 500 different sets of recommendations it's giving you as a result. And that will include software libraries. It includes everything. So it's entire recommendation. So over the 500 iterations, different prompts are giving you different answers. So chain of thought and tree of knowledge. Well, chain of thought is particularly focusing on token management. Now, we have already told it tokens are an issue. Belbin is given a reasonable response here. Document chunking. And then it's gone through document partitioning. Then it's gone through token management. So this is okay. Tree of thought has been okay. It's been reasonable. But the different responses give different answers. The different power prompts are given as different recommendations. If we look, so we have essentially, we have 2,500 recommendations. So if we take the top 5 recommendations for each iteration, so we're taking essentially the top 25 recommendations for each prompt, the top 25 recommendations when we don't include a power prompt, when we use step by step, when we have tree of knowledge, when we have Belbin, we have tree of thought. And when we do that, essentially it gives us very similar outputs. So sliding window is quite a popular recommendation here. The Belbin puts it slightly lower. It's pretty balanced no matter which power prompt you use. There is a difference, and that's if you don't include any power prompt. What it does is it will give you software recommendations about how to achieve each of these tasks, the libraries, particularly in Python that we're using. And it really underrepresents the powerful libraries if you don't include a power prompt at all. Okay, so I think the take-home message here is that the Belbin prompt here succeeded, going back to the original analysis, because it was able to identify the data issues, and it could successfully identify which ones it would be the problem, were going to be an issue, even though we've not actually asked it whether we think data is a problem. Okay, so to summarize the output here, what the Belbin prompt does is it maintains an out-of-the-box view of the total SDLC. It could see lost in the middle was a problem, but it only identified it 65% of the time. And it suggested that data issues, which in this retrospect is the right answer, were at the other side of the coin, were the other problem in this. If we look at the top 5 recommendations, or really the top 25 recommendations, then all of the prompts, all the power prompts, are very similar to each other. So you go down to a very granular level. Although if you didn't include a power prompt, at all, what you got is 40%. There was a 40% reduction in the libraries that you needed to solve that problem. It just wasn't as detailed as any of the other power prompts. Okay, so how are we doing for time? So to summarize this, we've introduced the idea of the Belbin committee prompt as a way of solving complex problems. So this is not a day-to-day, tell me this, tell me that. It's when you're making a problem solving, asking it to do problem solving, or you're asking it to do planning. And in that, when we look at section 1 of our analysis, so this was the generative AI training example, the Belbin Prompt 1, hands down, it was the most successful power prompt in all of those used. When we went to section 2, we wanted to summarize complex data within the LLM, and that has a wide range of applications. In this example, we use prostate cancer. The tree of knowledge, you use a tree of knowledge prompt. That one at data summarization, that was under a technique called iteration. So all of these are under iteration. In section 3, the software development lifecycle, in this analysis, the Belbin prompt correctly identified 2 SDLC choke points when every other approach failed. So essentially, the Belbin prompt is able to override a single shot or a few shot prompt and reach its own conclusions. So by implication there, it should in some ways outperform a RAG in some limit in given situations. So this is a prompt that I developed. It was initially to overcome problems in a training exercise, but then it was later used for successful deployment into the SDLC, and it's not the only time I've used it. And after using this prompt over a long period, this is not part of formal analytics, but this is my personal observations. What the Belbin prompt was able to do is navigate between an hallucination and over-tightening. So in the examples I'm showing you, what the prompt is doing is it's over-tightening around the example being given. That's the critical point here. And it cannot, as soon as it gets hold of that example, it cannot see beyond it. The Belbin committee is able to see beyond it and avoid hallucinating. So I have come up with situations where the LLM has hallucinated, and the Belbin prompt brings it back and avoids that hallucination. So all in all, I would say that this is a very successful approach to zero-shot prompting. And then the other one we covered, I developed this idea of use a tree of knowledge, and this is successful at summarizing large amounts of information within the LLM. So thank you very much for your time. I hope my talk has been of value. Just to mention, this is not the only time I've successfully solved an SDLC with the Belbin prompt. I had a similar problem in a biomedical example recently concerning a AWS framework, and it was a difference between software packages implemented through Conda and deprecated versions that I was importing into Docker within the AWS framework, and it was able to identify the problems of deprecation in there. So it has a broader overview than simply this example I'm giving you, but this example I'm giving you has been through formal analytics. So for future useful links, if you want to look at what a Belbin committee is, belbin.com will explain that for you with Team Roles. For the books, what I was really doing throughout this was looking at O'Reilly's Prompt Engineering, Phoenix and Taylor, 2024, Prompt Engineering for Generative AI, and then issuing an improvement on the prompt engineering it was suggesting. That's what I was basically doing. And for our communities, please do check out GenAI India, GenAI X Poland, Global GenAI X, and the GenAI that I'm part of, which is a LATAM community, DataZen LATAM community. That is everything. And this is where I live right now, halfway up a volcano, Popocatépetl. I think it is very beautiful. And I think it is a very positive metaphor for the future of GenAI as we see them through large language models. So thank you very much for your time, and the floor is now open for questions.
Yeah, thank you very much. Very interesting topic. So, and so maybe the first question, should does so is the Belbin framework already a part of model training, or you need to add anything like to need to teach like LLM what is Belbin framework?
No, you do not need to teach the LLM what is the Belbin framework. It already knows it, so it's already part of any of the major LLMs. The Belbin committee framework is part of that. It is part of its internal training. So as soon as you introduce the prompt, solve this using a Belbin committee, you have to specify with team roles. Okay, as soon as you specify that, it will trigger the Belbin committee, and you get this very large output where it's looking between the different committee members and deciding what the right answer is. If you do not specify a chair's report, the generative part of it will not always spit out the chair's report. So you would have to ask it for the chair's report. So within the Belbin committee, there will be a chairperson, and they will summarize the whole argument. So sometimes you just have to ask it. So there's no training needed. It's not part of an accelerator. There's no transformer. It's part of every single major LLM.
Yeah, and one more question regarding those yellow notebook. If the question was where is notebook, why answer identifying things like security issues is better than simply location of this notebook?
Well, that depends on. It depends on the issue. The underlying issue for the question is that in many major companies, writing down your passwords is not permitted, and putting your passwords in a notebook that you're taking into your workplace would not be part of your company policy. So the point is that if you wanted just to answer the question, if you have a question and you want that exact answer to that question, then this Belbin prompt is not the right way to go. You could use a chain of thought, you could use a tree of thought, and the tree of thought method gave you one solution. It gave you one output for that, which was it was in a badminton court. So it depends what you want. I mean, if you want it to look at all the perspectives and all the things that you've not thought about in the question, if you want it to do that, to give you the broad overview of everything, all the issues, and if there's something you've missed, it's going to pick it up, the Belbin prompt is the right way to go. If, however, you've got an exact question and you want an exact answer, then in that case, using the Belbin prompt is not the right way to go. Using something like chain of thought or tree of thought is a better approach.
Okay, got it. Yeah, interesting. Need to experiment with it. Haven't used it before, fortunately. Yeah,
Right.
Thank you very much for this interesting presentation. Thank you everyone for joining today our discussion. And in the description, you will find the link to access the presentation file and the recording. Also, on this event page, you can award a speaker a badge and rate this talk. Yeah, if you like it, or maybe if you don't like it, or maybe if you have some other opinion, yeah, please share in comments. Be sure to subscribe to our channels to get more content like this, and we hope to see you on our next session in Winter Data Meetup. Yeah, thank you very much.
Great. Many thanks. Bye.
Thank you.